Hi everyone, this is Vaibhav Shrotiya. My roll number is 1018060054. I am here to present my research work titled Development of Novel Algorithm for Salt and Paper Denoising, which is carried out under the guidance of Dr. Bharat Garg. Problem statement was to develop and improve denoising algorithm for salt and paper noise. Image denoising has always been an issue for the researchers and it aims to recover noise-free images from the contaminated ones. Impulse noises added to images during the acquisition, transmission, receiving, or the storage phase. Noise can be of two types. It can either be a random valued or a fixed valued. Salt and paper noise is a fixed valued noise which can either attain 0 or 255 when corrupted. And whereas in random valued noise, contaminated pixel can attain any value. So the research objective was to suppress the noise from the image and at the same time preserving the texture and the quality and the fine details in the image. In this research work, I have tried to propose a better filtering algorithm for sap noise removal. This is the research methodology that I followed. First one was to understand the research objective, then going through the previous work, simulating the existing work on MATLAB, the tool that I used for the coding, and then the comparative analysis of the existing algorithm to see what they lack. Then we worked on the novel design and based on the trade-offs that is, it can either be the processing time or anything. Then we simulate the novel design, the novel algorithm, and then the comparative analysis of the novel algorithm with the existing ones to see if it performs any better, and then writing the research paper about it. Moving on, these were the five milestones in which I have divided my research project. First one was literature review, then development of novel algorithm. After that, it was comparative analysis, simulation of developed algorithm, and finalizing the research and demonstration of denoising filter. So during the literature review, I have gone through these existing algorithm, and in the upcoming table, I have concluded them based on their filter type and drawback. As we can see that FSB MMF does not have any drawback that I can find. Most of them have drawback at high noise density, and most of them are median filter. Moving on, these are the two proposed algorithms that I propose in this work. First one is intensity bound limit filter, I named it as IBLF, and then the distance and intensity bit separation DIPS. We would be looking at each one of them one by one. So an intensity bound limit filter is a two-stage filter in which in first stage we make two copy of the images and limit them by upper and lower bound of intensity. And in the second step, we reconstruct those images using the reconstruction and smoothing filter. Moving on, this is the flowchart and the hardware structure of the proposed algorithm. As in the flowchart, we can see that we input a noisy image which is converted into two copies. One is called as infimum, that is lower bound, another is suplinum, that is upper bound. Then we identify the noisy pixel in image and initialize the window size at n equal to 1, that is 3 by 3. Then if there is no noise free pixel in the window, then we increase its size. And after this step, as we can see at the below in the red square, we see that we have reconstructed the image using the mean of the infimum and superinum image, and that's how we get our reconstructed image. This is the hardware structure of the same. So these are the result. For standard images, we are getting an average improvement of 0.76 dB in PSNR and a peak of 1.11 dB in PSNR value. For SSIM, the average improvement is 1.01%, while for the Kodak images, we are getting average improvement of 1.03 dB in PSNR and peak improvement of 1.69 dB. While for the SSIM, this average value is 1.2% and the peak is 3.09. So these are the charts for the standard and Kodak images respectively. Now the second work that I have done is the DIBS, distance intensity based separation filter. This also consists of two stages. In first stage, we divide the pixels into two classes based on their distance from the central pixel. And in the second step, we recombine all those uh, classes and get the output image. A detailed work has been submitted in the form of report. This is the algorithm and this is the hardware structure. As we can see in the algorithm, first of all, we input the noise image, then and we get an estimated output image. If a pixel is noisy, then only we process it. We see its distance from the center pixel, and then we take the mode of all the distances, and then based on that, we output our image, the final noise-free pixel. Moving on, this is the conclusion that we get of the from the standard image when they are processed from 10 to 90% noise density, and there was an average improvement of 0.84 dB in PSNR, peak of 1.28 dB, and an average improvement of 2.16% in SSIM. For the Kodak image, these values come to be 1.03 average improvement in PSNR, 1.1 dB a peak improvement in PSNR, 2.2 dB average improvement in SSIM, and 3.5 dB peak improvement in SSIM. These are the two PSNR charts. First one, left one is for standard image, and the right one is for Kodak image. We can see that our filter performs better. It can be seen visually here. This was the complete timeline of my project. So first one was the phase one, where I selected the idea, validated the feasibility, learned the MATLAB, and did the literature review. Then comes the phase two, where I implemented the existing algorithm, then the comparative analysis of existing algorithm, and development of novel algorithm. In phase 3, I tested the novel algorithm on benchmark images and comparative analysis with existing algorithm. In phase 4, I did the hardware part, and in phase 5, I prepare the final report, final presentation, writing research paper, and the final evaluation. Thank you.